Welcome to tonight's video on zeros of polynomial functions. Talking about the rational root theorem. The rational root theorem tells you how to create a list of possible rational zeros. The most important terms are the constant term. This is what we call the p. That's the constant term. And the q is what we call the leading coefficient. All right, and what we do is we factor both of them. So the factors of the constant term and the factors of the leading coefficient, and that helps us get our possible zeros. So for example, here our p is equal to 4, the q is equal to -1. So the factors of p are plus or minus 1, plus or minus 2, plus or minus 4. The factors of q are just plus or minus 1. So when you divide all the factors of p by all the factors of q, you get plus or minus 1, plus or minus 2, plus or minus 4. So if we do that for the next one, here the p is 6, the q is 1. So the factors of p are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. The factors of q are just plus or minus 1. So when you divide, you get plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So you notice if the factors of q are just 1, or q is just 1, then basically the possible zeros are just the factors of p. However, that changes if the leading coefficient is something other than 1, which in this case it's 4. So now when you factor p, it's plus or minus 1 and plus or minus 3. But q is now plus or minus 1, plus or minus 2, plus or minus 4. So when you divide, it's plus or minus 1, plus or minus 1/2, plus or minus 1/4. So that's all the factors for 1. And then for 3, you go plus or minus 3, plus or minus 3/2, plus or minus 3/4. So this is your list of possible zeros, right? So same for up here. These are all the possible zeros. Now, what we do with that list is we can use it to help us solve the equation to find all the zeros, because right now they don't give us any. So we need to narrow it down to possible zeros. So here, p is 6, the q is 1, so plus or minus 1, plus or minus 2, minus 3, plus or minus 6, and then q is plus or minus 1. So we go p over q. So these are all the possible zeros. So now what we do is we take from this list here and we start doing synthetic division to see if any of them are actual zeros. And remember, if they're going to be zeros, our remainder when we do synthetic division should be 0. So if I start with 1 and do synthetic division, notice, bring down the 1, multiply, add down, multiply, add down, multiply. Notice this has a remainder other than 0, so 1 does not work. So try -1. So I'm just going to keep trying until one of them works. One of them gives me a remainder of 0. 1, -1, -6, 6. Notice, so now this gives you, so this means it's a 0. So -1 is one of the answers. Now you're going to take the remaining polynomial here, which is going to be x squared plus x minus 6, and set it equal to 0. And then you factor it. So you get x plus 3 and x minus 2. So x equals, so you set those equal to 0. And you get x equals negative 3 and x equals 2. So your three answers are x equals negative, I'll just put it least to greatest, negative 3, negative 1, and 2. Those are your three answers. So let's look at the next one. So now here, the factors of 20 are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. The factors of q are just plus or minus 1, so that means p over q is just plus or minus 1, plus or minus 2, 4, 5, 10, and 20. So this is the list that we're going to go for. This is our possible. So now, starting with 1, we have to do the synthetic division. Bring down the 1, multiply, add down. So notice when we do this, the first number gives us 0. That's always nice. But if it doesn't, we just go to the next number. So here it's x squared plus 9x plus 20 equals 0. So notice when we factor, we get x plus 5 and x plus 4. So when we set these equal to 0, we get x equals negative 5, x equals negative 4. So our list is negative 5, negative 4, and 1. Those are the three numbers that work. All right, so for this next one, notice p is here, q is here. So it's plus or minus 1, plus or minus 3. Q is just plus or minus 1. So p over q gives us plus or minus 1, plus or minus 3. So notice we do synthetic division. 1, 7, 11, negative 3. Bring down the 1, multiply, add, multiply, add, multiply. Notice this doesn't work, so let's do negative 1. So 1, 7, 11, negative 3. 1, negative 1, 6, negative 6, 5. Nope, this does not work either. So now we got to try 3. 3, 10, 30, 41, a whole lot, 82, 123. So this is 120. So negative 3 should work, but let's just put it in because it's the only one left. 1, 7, 11, negative 3. So now let's bring down the 1. 0. All right, so we're left with x squared plus 4x minus 1 equals 0. Now, that is not factorable. And also a hint is that we used all the rational zeros. So negative 3 is our only rational 0. So to solve this, we have to do the quadratic formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So then let's simplify this. So we get negative 4 plus or minus the square root of 16 plus 4 all over 2. And then it's going to be negative 4 plus or minus the square root of 20 over 2. And when you simplify the square root of 20, you get 2 rad 5 And then all of these are divisible by 2, so you get -2 plus or minus rad 5. So those are your other two answers, -2 plus the square root of 5 and -2 minus the square root of 5. So those are your three answers. So yes, it is possible that answers are not rational. In this case, this would be the two irrational. Now notice what happened when the zeros were not rational, right? You had to use the quadratic formula, and notice they came in conjugate pairs. So that's what happens when they're complex, meaning it has an I in them. If a plus bi is a root, then a minus bi is also a zero or root. So for example, if they tell you 3 plus 7i is a root, then you know 3 minus 7i is also a root. If -2 minus 5i, then -2 plus 5i is a root. If -4i, then positive 4i. If 3i, then -3i. So if you have complex roots, that means the conjugates, they come in conjugate pairs because of the fact that you use the quadratic formula to find those roots. All right, that's important because here it gives you the example that -2, 2, and I are zeros. And it tells you that when you put 3 in the function, you get 150. And you're going to build, so you're going to work backwards. You're going to build a function with those characteristics. So first, what you're going to do is -2, 2, and I are zeros. That means also -2, 2, I, and -I are zeros. So you're going to write this as factors. So it's going to be f of x equals a. A is just the leading coefficient. And then it's x plus 2, x minus 2, x minus I, x plus I. All right, now you're going to multiply out x, but don't distribute the a, leave the a out. So for example, here, when you multiply conjugates, it's just a squared minus b squared, so it's x squared minus 4. And here it's x squared minus I squared. But remember, I squared is -1. So it's really x squared plus 1. And then you FOIL here, so you get x to the 4th minus 3x squared, and then minus 4. So you just FOIL that. So there, you multiplied it out. You just didn't distribute the a because we're going to find the a. And what we use to find the a is the fact that f of 3 is equal to 150. So when we put in the 3 here, so 3 to the 4th minus 3 times 3 squared minus 4, that it has to equal 150. Well, 3 to the 4th is 81 minus 9 times 3 is 27 minus 4. So 81 minus 27 gives you 54 minus 4 gives you 50. And then when you divide by 50, notice that you get a equals 3. So what we're going to do is put that 3 in for a. And then we're going to distribute. So we get 3x to the 4th minus 9x squared minus 12. That is the function with those characteristics. So let's do it again. So here we're trying to find a third degree. So there's 3 answers with -3 minus 2i. So that means that it's also positive 2i is a 0. right? That the conjugate only works with complex, so -3 does not have to mean 3 is an answer. It's only when it's a complex 0, so when it's imaginary. So this tells you, if you write it as factors, that it's going to be some number times x plus 3, x plus 2i, x minus 2i. So let's distribute. Now remember, multiply the conjugates first. That'll make your life easier. So this is x squared minus 4i squared. So it becomes x squared plus 4 when you put the -1 in for I. You distribute, so you get x to the third. You get plus 3x squared plus 4x plus 12. All right, so now you're going to put sorry, this is G. You're going to put 1 in. So when you put the 1 in, you're going to set it equal to 100 after you simplify it. So you get 1 plus 3 plus 4, so 4, 8, 20. So 20a. So then when you divide by 20, you get that a is equal to 5. So you know that g of x is equal to 5 times x to the third plus 3x squared plus 4x plus 12. So you got to distribute. So it's equal to 5x to the third plus 15x squared plus 20x plus 60. That is your final answer. All right, so let's do the next one. This one's a 4th degree. It has 0, 1, and 3i as zeros, so that means it's 0, 1, 3i, and -3i. So when you write this as factors, it's going to be some number times x minus 0, well, that's just x minus 1, x minus 3i, x plus 3i. So let's multiply that out. So here, when you multiply it out, you get x squared minus x. Here, when you multiply it out, you get x squared minus 9i squared. So then, this becomes x squared plus 9 when you put the -1 in for I. So then you distribute, you FOIL, so you get x to the 4th minus x to the 3rd plus 9x squared minus 9x. And it says when you put -1 in, you should get 40. So -1 to the 4th minus -1 to the 3rd plus 9 times -1 squared minus 9 times -1. There. All right, so then -1 to the 4th is 1 plus 1 because negative, it would be minus a minus. -1 squared is 1, so plus 9, and then plus 9 again. So it's going to equal 2 and 18, 20. And f of -1 is -40. So when you divide by 20, you get -2 for a. So that means when you put -2 in for a, and then you're going to distribute it, you get -2x to the 4th plus 2x to the 3rd minus 18x squared plus 18x. All right, that concludes our notes. All right, if you have any questions, please feel free to come by during iBlock or after school the next class. All right, I will see you guys next class. Have a good evening.